today?
It's SQL today, right?
Okay.
Yeah, SQL today. Hi, Tom. I want to apologize. I've been MIA, missing in action, for the last few sessions, but hoping to get back to it. It's good to see.
I just came off mute to say hi. I'm driving.
Yes, you're
Everyone's
in a car.
mad at me for zooming and driving, but I'm going to go on mute and off camera and listen.
Okay,
okay.
I love that Tom is in a car.
And I just want to. Can I give Tom a quick update on the challenge I'm facing?
Yeah, sure.
Because I've been a bit MIA as well, but for Tom, the issue with connection to the little project I'm working on, VS Code has an SSH development environment that you can connect directly into Linux and do everything, have all the terminal to yourself, and you can do Python and JSON through the development module.
Nice.
So it was a big achievement.
Well done, Jonathan. I hope it works out for that project.
I hope so.
All right. So
one thing also before you start, please, I have to announce this. During the coming week, I will cancel the previous invitations for the class and for the mentoring, and I will share a new invitation with the new link, because it will be integrated MLAI Zoom account. It's not deep learning AI Zoom account. So this is just for you if you receive the invitation, the new invitation, to accept it and save it to your records. And now I'm done.
I love it. You're becoming a turtleneck man now that you're in colder weather. It looks good. You got the look down. Let's see how many people we can get. I want to wait for there more people to sign up. So Donabel, how's Canada right now? Is it cold? What's it like there now?
Starting to be fall. Yes, we've started a lot of downpours already. So kind of typical Vancouver, I guess. How about where you are? How's
it's been beautiful. So it was awful until about a week ago, and then there was lots of rain and nastiness, and now there's just beautiful skies and like 70 degrees, the spring we never had.
That's good.
So
came a little bit too late.
Yes, exactly. So I've been trying to stay outdoors as much as possible. Like when we called Tom for his birthday, I went outside. Had to be outside because it's going to be limited. I know it won't last.
Where are you located, Kimberly?
I'm in Brooklyn, New York.
Oh, okay, on the East Coast, I see.
Yeah.
So since we are waiting, I will share this with you just for fun. I received my residency card in Germany today.
Awesome.
Congratulations.
Now this is thank you very much. This is not the funny part.
Congratulations! You are officially here.
Yes.
Great.
Right now I'm able to go out of home. So
yeah.
A big deal, Gate.
There is one thing, really, it's funny, and until now I don't know why. And in the appointment and the interview for applying for the residency, they asked me two questions. What's your height and what's your eye color? I think there is something more important to ask for.
No,
so really, this is this is strange.
That doesn't sound to me.
That
doesn't sound. That doesn't sound strange. If I also had those questions in the Netherlands.
It's universal. Okay. You get those questions anywhere. Because
no, it's not. Okay, it's maybe in Europe, maybe in USA, but in Dubai, it wasn't totally different questions. Totally.
What do they ask in Dubai?
I cannot say.
Yeah, but if you look at your permit, your ID, it is recorded on that, right?
Yes, it's here. Yeah. Yep.
It is that. That's why they are asking.
Yeah, because it's a form of identification. That is your
Yes.
most official form of identification in Germany right now. You know, they
Okay.
ask the same for a permit here in New York. If you want to even get a permit to drive, not even a driver's license, you have to give all of this information.
Oh,
Because that's
okay.
that's a form of ID.
I'm not talking about the information itself. It's okay, but I thought maybe what's the third question? Okay, no third question. That's enough. Okay,
So what do you think the third
so
question?
I'm Rais with this height, with this eye color, and that's enough.
Yes, it gives lots of opportunities for mistaken identity.
Yes.
If that's what you're worried about.
Okay, I will mute myself.
Okay, so you know, we're well into 12 now, so I'm going to start today. Hi everybody, welcome to Integrated MLAI. As you know, we are all into the idea of more together. And so today we have one of our favorite family members back again to help us this time learning about SQL. And Gaith, are we recording these? And if so, who's recording? Yeah, okay. Great.
Yes, it's already recorded. Yes.
Great. So so we have Donabel Santos with us. She is a SQL extraordinaire, Tableau extraordinaire, you know, dashboard extraordinaire person. You can see her classes on YouTube. If you haven't already, please do. There's lots to learn there. And today she is going to tell us about SQL. So Donabel, please take it away.
Thank you, Kim. Hello, everybody. Again, I'm so sorry I missed a few sessions. I'm going to try to catch up, but it's so great. It's so great to see everyone here. And as you said, it's like family. I hope it feels that way. So even if I haven't seen you for a while, it feels like, oh, I just saw them yesterday. So I hope everybody's feeling okay. And I'm going to share a little bit about SQL. It's really more of an introduction and maybe some field notes or field guides, things that I learned along the way. And I hope we can keep this pretty informal. If you have any questions at any point in time, please feel free to ask and mute. I'm not sure if I can monitor the chat actually, because last time when I promised it, I wasn't able to. So I guess I'm going to respond if there's any questions.
I'll monitor the chat for you.
Okay, thank you. So I'm going to share my screen. I have a little presentation here. And I'm just going to check. Are you able to see my screen?
Yes.
Okay, awesome. Thank you so much. Okay, so again, this presentation is really just more about SQL. And if you have any questions, please ask me. So I don't claim, I'm not an expert in SQL, especially how SQL has really changed over the years. But again, I'm going to share some of the foundational knowledge that I've learned when I was working with SQL, and I still do work with SQL. So again, this is just meant to be an introduction to SQL and databases. So my name is Donabel Santos. I'm a practitioner in the sense that this is something that I do pretty much every day. So the two main tools that I use in my kind of day-to-day is like SQL and Tableau. Now, in addition to that, I've also been teaching some of the SQL courses for a while. I've stopped recently, but for the longest time, I have been teaching some of the foundational kind of SQL classes at a local college called BCIT. So it's British Columbia Institute of Technology. Now, I just want to give a little bit of backstory on how I got into SQL. So I think there was a point in my life where I wanted to switch careers. So my original major and focus of study was geology. So when I wanted to switch to computers, I went to BCIT. So I'm a BCIT grad. The original topic or the original specialization that I had at that time, it was actually called client server. And can you imagine, like back then, client server, the thought of having a client and a server was revolutionary. And we're probably way, way beyond that right now. And even at that time, the talk of like thin clients versus the server, again, it was pretty revolutionary at that time. So that was kind of my area of study, and that required a lot of programming. So I remember we've been programming in like at that time, Unix, Linux, sockets. Like it's a lot of like really low level work. So bits and bytes, the assembly, the packets. I think I was probably okay, but when I got introduced to databases, I think it clicked more with me because it's more of something that I can see myself working in. It's something I think I'm more of maybe I'm a little bit more higher level than kind of the bits and bytes. When I am given a question, I tend to think about the questions, but I can't really translate it very well to like the bits and bytes. So I think that's why I gravitated towards SQL. I also worked as a marker. At that time, a lot of the exams on the database, I was a marker for the database instructor. At that time, marking, the way they had exams was actually on paper. So you have like a 10-sheet exam or a 20-sheet exam, and all of those are questions, and you need to answer using SQL statements. So I was a marker for a number of years. And I remember like always going home and with a stack of like paper, and that's all I do for the weekend because I have to get the marks done by the next week or the next Monday. And it's just really reading a lot of SQL on paper. So I don't know if that's a great experience, but I think it helped me be able to read some of the SQL because I have to figure out in my head, does this SQL work? And I can't afford to like plug that all into a computer and then check it all the time. That's not gonna work with my time. But anyway, sorry, kind of rambled on, but that was kind of like my backstory on working with SQL. So I have been working with SQL for a number of years, more than a decade for sure. And the notion of databases really isn't anything new. And especially now, we have so many things that are dependent on data. And a lot of the systems that we have, they are running on some kind of database. And if we look again, 10, 20 years, 30 years back, a lot of those databases that we still probably look into, like a lot of the data that we look into, they are stored in maybe legacy systems and what we call relational databases. But I just kind of want to go back to what really are databases. And I'm not sure if you've seen this. I'm not sure if you're familiar with this, but this is called a file cabinet. It probably still exists for certain locations, for certain places, but this is what a database is. A database is really just a series of records that has information that is stored somewhere that we may or may not need to know about. So this is what the database is. And if you have this, if you have a little file cabinet at home, that is technically a database. But right now, the only thing that has really changed is we're still keeping track of a lot of data. Hi. Oh, sorry, I thought there was a question. So
sorry.
Go ahead.
No, apologies. I wasn't on mute. I was talking to one of the kids.
Oh, okay. No worries. No worries. Yeah. So in here, the only thing that really has changed is it's not our need or affinity to collect data and query data, but it's really the capacity to collect data and how we collect it. So we've digitized a lot of these. So imagine before, if you have a room full of file cabinets, if you have like a library full of file cabinets and files, it would take you a really long time to look for, to find what you're looking for. So that has to be really organized. And right now, we actually just exponentially made this much bigger, much wider. So so that's I think that's where the state that's where we are right now. So we're still working with databases. What databases look like, it's probably a little bit different now, but it's still databases. So what is SQL then? Like, where does it fit into this picture? So SQL stands for Structured Query Language. And it is a declarative language. It is a language that we can use to describe what we want to do, describe what we want to get. And it allows us to talk to a database. And again, that could be different kinds of databases. It could be a relational database. It could be a non-relational database. But it doesn't change the fact that it is a way to translate. So I like analogies. So in here, the way I can think of it is it's a translator. I'm going to say, you know, I want this, I want food. But then there is this translation language. So if this is the language that I know, then it gets translated to what I need it to be so that I can get what I need. And again, that's how I think of a SQL. It is a way to translate because that is a totally different language. The databases work with a totally different language. So in here, I start thinking about SQL. SQL has been around for a really long time. And is it outdated? Well, I guess yes and no. It depends on where you're coming from. But, you know, I kind of looked at the news last night and, you know, some of the styles from the 70s and the 2000s are back. So, you know, SQL is really probably coming back. I remember a point in time when I was working, because I work mostly on the SQL, on the relational database side. And I remember, I think maybe this is about maybe 10, 15 years ago, and people are saying, you know, SQL's going to die, SQL's dead. We're not going to need this because of the advent of big data. And because relational databases at that time is, even right now, is really considered small data compared to all of this big data. So I kind of started thinking about, you know, am I going to get unemployed? Am I going to lose my job? Do I need to upgrade? What else do I need to learn? Maybe I don't. Maybe I need to stop working in SQL. But through the years, even after that kind of big flood of different kinds of databases, and in here, what I'm mentioning is what's called NoSQL. So NoSQL. It actually means not only SQL, but there was a point in time where it is interpreted as NoSQL, period. So at that time, we have a lot of systems that use a totally different language. So it is a database, it's a massive database, but it's using a totally different language to get data out. But in the last 5 years, a lot of these systems, they have developed interfaces that are SQL-like. And so this is kind of my personal opinion or my personal observation is SQL is actually not going to go away. It is something that a lot of people can understand. So it dates back to like 1970s. It's a lot of people can understand it, and a lot of people can are still. It's still something that people can connect to and can understand. So that's why a lot of the systems, they have SQL-like statements, they have SQL-like features. It's still kind of a standard in pulling data from a data collection or data resource. So again, is it outdated already? From where I'm standing, from what I see, I don't think so. Maybe there was a point in time where it's kind of like the old technology, but it is really embedded in a lot of the things that we do. So to that point, I also just wanted to mention that when we talk about SQL, it's actually many different things. It's just like talking about ice cream. When we say ice cream, we kind of know what it is, but there's many different kinds of ice cream. There's many different flavors of ice cream. And even kind of, you know, the chocolate ice cream for one vendor might taste very different from the chocolate ice cream from another vendor. So this is what we call flavors. When we talk about SQL, it's actually, there is a universal construct. So we have what we call kind of the standard or the ANSI SQL. These are kind of like, it's almost like a guideline. So a lot of vendors that are trying to implement SQL, like these are the expectations, but they are just guidelines. So the flavors of SQL, at least from the relational database side, so these ones are RDBMSs or relational database management systems. A lot of them, they have SQL. So these are databases, database management systems. They have SQL, but their implementation might be slightly different. So for example, so some of the common ones, Oracle, we have PL SQL, or it's called procedural language / SQL. For SQL Server, if you work on the Microsoft stack, it's called T-SQL or Transact SQL. Now, the other kind of really popular common relational databases, we have Postgres, we have MySQL, and MySQL kind of forked after Oracle bought MySQL. Now we have another version called MariaDB, and we also have SQLite. And again, a lot of them have different implementations of SQL. The statement that I run on Oracle will probably not run on Microsoft. The one that I develop on Microsoft may not run on Postgres, and same as MySQL. So again, we just need to be aware of the different flavors. Now, as I've mentioned earlier, there's a new set of databases. We have unstructured databases. We have document databases, graph databases. And in the past, a lot of it is pretty programming specific. So you need to know how to program. But right now, there's actually a lot of interface where it will ask you for something that is SQLite. So again, it's still a flavor of SQL. So for example, Cassandra has its own SQL. And again, for a lot of these, it is SQL-like. So the good thing about this, and again, I think when I'm presenting, it is from my perspective, and I appreciate and I respect that different people will have different perspectives on this. But from my perspective, what it allows you to do is it allows you to be able to take what you learn. So if you already know SQL, it means that it's a smaller jump for you to learn something else. So if I work in SQL Server and I work with a lot of SQL, I can take what I know, kind of the core concepts, and then just adjust the syntax, and I will probably be able to work with Postgres. I probably will be able to work with MySQL, because a lot of the differences are in the language, and not in the language, but in the syntax. So again, I think SQL is a critical skill. In my organizations, we have to hire people, and personally, for me, for the jobs that I work with, SQL is one of those. It's really critical for my work, and maybe it's different for different companies. But I think SQL is I think it's a good skill, and I would say it's a really good skill. But I might be biased.
Donabel, can I ask a question now, or would you want me to save it for later?
Yes, please do.
So the question on the flavors and on the left side where you have the ANSI ISO that table over there. So all this variety that's listed over there, right? When we're looking for data analyst, data science job, right? Which of this one in particular is what the company, or I mean not the company, the industry, the data science industry or data analyst industry is looking for? Is it SQLite? Is it PostgreSQL? Which one is the most popular, or what would you recommend someone who's starting out to learn?
I'm sorry. I'm trying to. I apologize.
No worries.
I'm probably a Zoom newbie. Oh, there's Jaya. Okay, Jaya. I'm trying to see who's speaking. So
that's me.
Yeah. So thank you, Jaya. I think it depends, because it really depends on the industry. So for example, if I'm going for a Microsoft, for a company that uses Microsoft, so they're on Azure, they use Power BI, I'm probably better served by learning Transact SQL. And there's a lot of companies that are running on Azure and Microsoft. If, for example, so at least from my experience, I've seen a lot of kind of bigger companies. So for example, banks, a lot of the banks, they run on Oracle. So you may be better served by learning PL SQL if your goal is to work in a bank and working on their kind of the big systems. In terms of, let's say, maybe more web-based or e-commerce, I think it's Postgres. I think it's a split. Postgres is really popular, and I think Vikram has mentioned, Postgres is open source. Oracle is more of a commercial, but I also want to caveat that with MySQL is owned by Oracle now, and it is still open source. It is still free. You still have an option to actually not pay for it if you don't want support. So I think it's really a toss-up. And a lot of the companies that maybe have started with MySQL, they probably still work with MySQL because it still serves their purpose. So I think that's why I don't think there's kind of like, just because something is more popular is the one that you're going to go with. But having said that, there is a lot of similarity. So if you're working with Postgres, And if you're working with MySQL and MariaDB, these are fairly similar. And that's probably easily translatable to Oracle. The syntax, the constraints, like even just the use of semicolons and such, I think they're very, very similar.
Okay, so let me ask you a second question then. So when all these courses, they say, oh, we have this SQL course, that SQL, Udemy has SQL courses, Coursera has SQL course. What exactly are they using? Are they using PostgreSQL, MySQL? How do we know?
I think I know what you mean. Like when I go through the courses and they say introduction to SQL, I always have to go to their description or sometimes to the table of contents, because you're right. When they say SQL, it means nothing to me. I don't know what kind of language they're really using, because they could be talking about MySQL. And if what I really needed to learn were specific things for Postgres, then I'm not going to learn those. Yeah. I think maybe just diving into the descriptions, and I can understand why they're doing that, or why the authors or the trainers are doing that, because SQL is more relatable. So if I were creating a course right now on SQL, I'll probably say SQL, because a lot of people will be looking for some kind of SQL. But if I put a course that is PL SQL, then it already narrows down my potential kind of audience. And I think
Donabel,
go ahead.
Just real quick for everyone, when I've had to translate between the different SQLs, W3 Schools is really great for that, for each of the types of commands.
Yeah. I think I've used W3 Schools too, and I think over the years, if I look at it, it's like, oh, this is like your SQL course right here. So they have really improved it over the years.
I want to add one thing about this, which is also Vikram. He mentioned it on the chat, and yes, I agree with you, Vikram. I think Vikram, I'm not sure. When we are talking about SQL for data science, it's the most important. It will be how to process and collect the data. So mainly they can be easily say that it's SQL that, because it's not about how you operate with your database. This is where the real change between, for example, PLSQL and TSQL appear. It's about how you operate toward it, how you are inserting and updating the information to your database. So that's why when we are talking about in data science, SQL is playing major role in data, let's say, manipulation and data collection. And here, it's almost the standard SQL. It can give you a great entrance for all environments. So this is the major. In data science, we are not talking much about the operational part of relational databases, where the main difference between these flavors, it's on that part, in the operational part.
Yeah, absolutely. ANSI SQL can get you a long way, because it kind of gives you the entrance point, and then you get to choose what kind of SQL you might want to specialize later on. Yeah, I think Kim, you also had a question.
Yes, thank you. So thank you so much for this great introduction. I love the way that you're taking it all the way back to the roots. And I wanted to ask a question for you, which I think might be helpful for people in understanding sort of how the industry is using things. And that is to describe the difference between relational databases and unrelational databases and how they work.
Yeah, absolutely. So I think what I can try. So when we talk about relational databases, and actually maybe I'm going to go here, it might be a little bit easier. Sorry, I have a lot of notes. Let's create a new note. There we go. So I think that's a great question, because I've mentioned it a few times, but I didn't really describe it. When we talk about relational databases, we talk about kind of the structures where you have tables and you create what's called relationships. So in here, I'm going to focus on what's called OLTP, so online transaction processing. And what this means is we're trying to store data very efficiently. We're not going to duplicate a lot of the data. And in here, what we tend to do is we create small tables. So for example, I might have a table called customer. And customer table will have all information about that customer, but the customer might be related, let's say, to sales. Customers might be related to maybe preferences. Customers might be related to, let's say, returns. So it could be many different things. But what we don't want to do is we don't want to duplicate the customer information. I want to be able to see your name just once. I don't want to repeat your name in sales as well, in preferences as well, or in return as well. Because what that does is it creates what's called anomalies. Because now you have to track every table that uses name and then update that if that needs updating. So with relational databases, basically what we do or what we create are tables that are related. And when we create those are called ER diagrams. So you might have table 1, again, that might be a customer. And then in here, that might be a product. And this might be sales. Now, with relational databases as well, a characteristic is it's always rows and columns. It's 2-dimensional. So what you get really are a column of values, and each column, so in here, if you have 4 columns, 4 of those columns, if you put values there, it makes up what's called a row or a record. And this is kind of at the heart or at the core of relational databases. You work with 2-dimensional tables that are structured in rows and columns. Okay. And again, for the longest time, I think this is probably what we've been working with unstructured, with the non-relational databases. It means that you are probably not as strict as to what we are storing in that database. For example, it could be images. So in here, if I have a database of images, I don't necessarily have to fit all the information for that image in a 2-dimensional structure. I'm just going to have to pull it as a binary information. But then we still probably need to query this structure. Other possibilities is maybe we're storing videos. Maybe we are storing documents. For example, right now we have live stream. Live stream is also a series of data, and at some point maybe we need to query it. So those are the non-relational databases because they don't fit into the traditional kind of 2-dimensional structures. Yeah.
Thank you. Great answer.
Yeah. Yeah. So, and I think Vikram also mentioned, non-relational databases can have dynamic schema. And in here, you're right. Again, like when I put a document in here, it could be a varying schema. One of the examples that I use when we talk about this, so another possibility is what we call semi-structured. So there might be some kind of a structure, but then it is dynamic. For example, let's say if you're a gamer, because I'm not a gamer, but then I worked for a company before where they actually forced us to play online games. So that was very stressful for me. I'm sure it was fun for other people, but creating my own avatar, figuring out, am I going to be a wizard? Am I going to be, actually don't even know what the terms are, or am I going to have, an armor? Am I going to get a gem? But think of those are data points. Those are data points that you're going to have to store somewhere, because the next time this person logs in, you probably want to pull all the attributes related to them. But that is semi-structured because we're not necessarily imposing that everybody has an armor. If you're not, if you're a wizard, you don't need an armor. So again, I think there are a lot of cases there. And I actually just kind of want to go back. Sorry, was that helpful?
Yes, absolutely.
Yeah, it's helpful.
Okay, thank you. So I think back to that question. So this question actually usually comes up too with some of my students in the past, because I think there are a few schools of thought, and again, different people will have different perspectives, but there's always, I see some posts, I see comments, and students sometimes comment that you have to learn just ANSI SQL because that makes it universal. And that is correct, because ANSI SQL is universal. It gives you an entry point to all of these, right? But I would say that there is merit into diving deep into something that is specific. And the reason for that, so for example, for my work in SQL Server, for Transact SQL, when my company or my organization decides to go with SQL Server is a full-featured relational database management system. It's actually beyond that now. But if I stick with ANSI SQL, it means that I am not going to take full advantage of the features that they have with the vendor. So usually the arguments with just sticking with Universal SQL is if you want to move around. So if next year I'm going to go to Oracle and the year after I'm going to go to MySQL, then I should have less problems kind of translating that SQL. But if, for example, your company is invested, let's say, in the Microsoft technology, you already have a big investment and you don't see yourself really moving in the next 5 to 10 years because of the big investment, and there is, let's say, ROI, then I would say that you're better served by looking at something beyond just the ANSI SQL, because you're going to be losing a lot. And I'm going to go back to my analogies. So it's just like buying a car. We can decide to, like purchase a car and it is enough for us to drive. But if I decide to buy a really specialized car, for F1 racing or something. But if I still kind of stick to just all the knobs that I know and not even touch the other knobs that actually made that car expensive, then I might not be getting my ROI. So again, I think it's just like my 2 cents, something to think about. I'm not saying that, you have to go into like to specialize, but just think of the kind of just the pros and cons of going kind of more generic. There definitely are pros, and going more specific or diving or specializing, there are definitely pros as well. So, and I'm pretty sure there are going to be a lot of discussions there. So in here, I kind of looked at it last night. So just looking at the trend. So it looks like from a SQL perspective for the relational database management systems, like Oracle still at the top, followed by MySQL, and then followed by SQL Server. So they're kind of like the top 3. And then kind of behind it is Postgres and SQLite. And I think SQLite is more of, if you need something that's embedded on a device, SQLite will be the appropriate database for that. Now, I want to go to just quickly to the sub-languages. When we talk about SQL, there's actually a lot of sub-languages. Actually, one of these, this is the first time I have heard of it, because when I was studying kind of my own SQL, I think we only had 2 then. It's like DML and DDL. But then now it evolved to like DCL, and then now there's DQL. So the 4 sub-languages are kind of 4 parts or groups of statements that generically we can apply when we're working with databases. So the first one is query, and query is really all about the select statement. You're querying, you're getting data. So this is your DQL. Now, if, for example, we are manipulating the data, so we need to insert a record, update a record, or delete a record, then that's kind of the sub-language called DML, or data manipulation language. Now, if we are not working with records, and if we are working with the actual data structures, we're creating the structures where the records are going to go, then that is your DDL. And for the most part, this is for create. So we're creating some kind of structure. It could be a table, it could be a view, create, alter, and drop. These are the most common ones. And again, the different implementations of SQL, of relational database management systems, they might have a little bit more. And the final one is actually DCL, or data control language, because everything in our database will need to have some kind of user access or user administration. And this is when we need to grant access to something or someone, or revoke access to something or someone. So these are kind of I think these are fairly generic. You go to one database, they will have most of these. Okay. So in this case, when we start working with SQL, what are the ways for us to work with SQL? Well, there's many different ways, and I think some of these will fall to preference, and some of these will will fall to need. But we can work on it using the command line. And I think Jonathan mentioned earlier, like he has like a Linux box, and he has SSH, and that's mostly command line. So in here you can kind of open up a connection to your database and then start typing in your statement. Some of us may work from the UI, from the user interface, or if, for example, this is something that's embedded somewhere else, it could be from a programming language. So if you work with Java, you might embed SQL into Java. If you're working with Python, you might embed that language to Python. So just some examples of the interface. This is what SQL Server looks like. So this is called SQL Server Management Studio. And for a user interface, it probably works if majority of the time what you need to do is querying, getting the data, maybe validating the data, and not really integration. So you're not necessarily maybe having to do this from a specific tool. But usually the way it works is you're going to have objects on the left-hand side. You're going to have your queries. And then once you run your queries, you're going to see some kind of results. So this is what Management Studio looks like. I've actually pulled in what MySQL Workbench looks like. So this is the user interface for MySQL. So kind of similar structure. So I think you can kind of see now that even the UI, if you know one, you're probably going to be able to use the other one more easily. So all the objects are here, and the queries right here. If I run it, I'm going to see the results kind of down at the bottom. And the final one, this is pgadmin. So for Postgres, again, similar interface. Different things though, they have different objects altogether. But again, there's a lot of similarities that if you learn one, I have very little doubt that that you won't be able to learn the other one. I think you should be able to learn the other one pretty easily. So I do want to focus for the next few minutes. And if I'm going over time, please let me know. I'm not so sure if I timed this.
Not at all, don't worry.
Okay, thank you. I do want to focus on DQL first, so the select statement. So, and I think we kind of mentioned this. This is what an ER diagram looks like. So ER diagram is usually kind of a visual representation of like entities or tables, and then their relationships to each other. And I think it's important for us to be acquainted to looking at ER diagrams, because when you're working with SQL, especially in transactional databases, you're going to need to know how to connect the dots. I always think of it as like puzzles. Like if, for example, I need to know, in this case, this is the pubs database for those of you who've used SQL Server. If I want to know the authors and the books that they published and which publishers there are, I basically have to connect the dots. I need to know how to get one from the other. So in here, these relationships are helpful to me because it tells me how to stitch the data. It tells me where to get the information. So I think knowing how to at least traverse the ER diagrams will go a long way. Now, syntax. There's a universal syntax. This you have to just memorize. When you're writing SQL, it has to be in this order. Otherwise, it's going to be incorrect. Select, from, where, group by, having, order by. That is the sequence. If you accidentally put the having right after the select and from after the order by, it is going to be syntax error, regardless of which. In here, I have to qualify that I'm talking about relational databases. So I know there are slightly different orders when you are working with a non-relational database flavor of SQL. Okay, so this is the syntax. If you're working with relational databases, you just need to memorize this: select, from, where, group by, having, order by. And what these are: select gives you, what fields, what record points do you, what data points do you want to display? From determines where it's coming from. Where is your filter? But this is your filter at the row level. If for some reason you need to have a grouped value, then you're going to have to group it by certain columns. Okay, and then having is your filter for the group. Okay, and then if in your display, if it is important, you can order your display. But this one, I would probably put a question mark because it really depends on the end product, on what you're trying to do with this. In some cases, maybe that is necessary. But if we're simply transferring the data to a website and on the website, they're doing a different kind of sorting, then you probably don't want this. Okay, so, but in terms of syntax, or besides syntax, I think what's more important is what we call order of operations, because this is really how, so the order of operations will help you in understanding first how to get it. Like, I think it will help you compose your SQL statements, but the order of operations also help you when you're tuning your SQL statements, or when you're refactoring. If somebody asks you, you know, for the whole world, how many people in Canada that are aged, you know, 30 to 50 speak French? Well, to answer that question, we have to think about where we're going to go first. Well, okay, we need to go to the world. We narrow down to Canada. Then we narrow down to a group of people within a specific age range and a specific language. And essentially what we're doing is the narrowing down is the from. So even though it appears second in the syntax, that's really the first thing that your database engines will look at. It's the from. Where is it coming from? And then the where is narrowing it down. So again, the reason this is helpful is because when we start creating a lot of queries, and especially if you have a lot of data, this becomes important because your choices might mean the difference between a poor performing query and an efficient query. And in some cases, that spells all the difference. It could be a 10-minute query or a 10-second query. So order of operations, typically we just need to narrow down where is it coming from? How do we filter it? Do we need to group it? And then filtering it by the group. And then the select statement from the syntax actually drops down, because ultimately you need to get the list of all of your records first that match your conditions. And once you already have the list, then you can cherry pick. Maybe I only want this column and I only want that column. Okay, but you still need to narrow down the data first. And some constructs that I would recommend you learn, like once you are comfortable with the basics, these are ones that I personally use pretty much like in a lot of the projects that I've worked on. So subqueries is basically an ability to embed a query within a query. Again, there are many different considerations, but knowing this, so the good thing about subqueries is if you know how to write a select statement, you know how to write a subquery, because it's a select inside a select, but the way you construct it might be a little bit different. Another one that comes to mind is what we call CTEs, and I see it in a lot of different database management systems. So CTEs are common table expressions. Also, we have views, basically just a constructed, it's a stored SQL statement. We also have stored procedures if there is something that is that probably has multiple tasks or multiple lines, so we can encapsulate that in a stored procedure. Also have functions, we have triggers. So there's a few to learn. And this is where the different kinds of flavors will be starkly different. So we may learn the basic select statements, but the moment we start getting into, again, getting more power out of that relational database, the way you create stored procedures in MySQL, it is fairly different. The considerations are going to be very different than if I'm working with SQL Server. So again, these are things to just kind of think about. Also, so I just want to end with some field notes. With SQL, similar with Tableau, and I think I might have mentioned this in the past presentation too, I would say question and context is still the most important. Don't just dive in and write your SQL. Think about the question. What are you trying to get? And also don't make assumptions based on what you see on that diagram. It's very misleading to think that if I know the relationship and there's a primary key and a foreign key there, that I can join them. It's very easy to think that that's right, but experience tells me it's not. It's always about the question. And just because column names can match and you run your SQL and there's no errors, it doesn't mean it's right. So again, always go back to the question, always have a way to check if what you're getting back is right. because it's easy to walk away after your query has run and say, yeah, I've done that query. Because it's all about answers, again, all about the questions. I would also say establish some conventions. So I personally like writing the keywords on their own lines, and then followed by, let's say, a column, comma. We have from, and then the other conditions. But for other organizations, maybe they don't like this. Maybe they just want the from right after the select statement. I think it doesn't really matter which convention you use, as long as you know your convention, and as long as the teams, the members of your team are following that convention, because readability is important. It's not underrated. When you write SQL, that's not the last time you're going to work with that SQL. I can guarantee you're going to go back a few times, maybe many times, to troubleshoot, to change, maybe to train somebody else. And if it's not readable, it's making your work harder. I would also say learn how to query the metadata. It's not just all about, it's really not just all about the query. It's not just all about some of the records. Sometimes it matters to know how to work with the metadata. I do want to show a very, very quick demo of what this means, or what I mean by this. But just the final one is being able to execute does not guarantee correctness. It doesn't guarantee performance. It also doesn't guarantee maintainability. Just because I was able to run a query right now, it does not mean it is. So let's say if I run a query, I get the correct results right now. We also have to think about what we call scalability. It might work right now because I have a few hundred records, but what if I have a few thousand records? What if I have a few million records and there are 100 different concurrent connections to that same thing? Will it stand? So it's easy to think of the small things right now, but when we start deploying this to having more people use it, that's when things might start falling apart. So it's never too early to think about performance, and it's never too early to think about maintainability, because the best case is, our business is successful and tomorrow we have 10 million new subscribers. That's the best case. So are we going to hold up? And we can at least start thinking about it or preparing for it. So I just wanted to give an example of what I mean by querying metadata. So I do have a management studio here. So for example, I have, right now I work with a database that has 50,000 tables. So if I want to know where my IDs are, like I can't even generate an ER diagram. But if I want to know like which databases or which tables have, a name, if you know how to query the metadata, and this is one that's going to be very specific to the system. So in here, it's for SQL Server, it's called information schema. And I have one kind of view in here called columns. So if I know how to query the metadata, so let's just select the top 100 star here. So in here, it will show me all of the fields. So these are all the fields that are within the current database. But if I'm looking for any column, so where column name, so column underscore name, like, and let's say percent, anything that has name, percent name, okay, and execute that. So instead of working with hundreds and hundreds of columns, I'm able to narrow down already, okay, well, these are the tables that I can look into. So again, that kind of just helps. And this is going to be pretty specific to the relational database management system. And that was it. Sorry, I thought it was a little bit longer than I
thank
thought.
you so much, Donabel. That was awesome. That was a great introduction. And I'd love to know if anyone has any questions. If anyone
I have
does,
one question.
Yeah, absolutely.
This is Jaya, by the way.
Hi, Jaya.
Donabel, if you go back to the slide on the ERD, the one with the map, correct? I like to understand a little bit about this map. So you've got these yellow keys going across the different, I'd say, tables maybe. Can you explain a little bit about that key and the relation to the different things and that other little symbol that you have up there, like that 8 sign, looking like an 8 sign?
Yeah, absolutely. So this ER diagram was generated specifically from SQL Server. So SQL Server, when we create tables and constraints, we can generate or reverse engineer and show it in a diagram. In other diagramming tools, it might look a little bit different. But the key in here, so for example, let's take a look at authors. The key in here is typically what we call primary keys. And a primary key is a unique identifier for that particular table. So in here, I might have a primary key of 1, 2, 3, and that is very specific to authors. Now, if I have tables that are related to that author, typically what we do is we create what we call constraints. And so it's a foreign key constraint. And what really that means is I'm going to need to use this ID in another table. So in this case, I have another table called author. I need to use that to relate these two records together. Now, the key in here means 1. So when we talk about ER diagrams and tables, we talk about what's called multiplicity. And multiplicity is how many instances of a record can relate in another table. And in this case, what we're saying is author ID, these IDs right here, they have to be unique. They have to appear just once. So that's the one. This is the one side. So in other diagramming tools, it might appear as like a 1.1. But what we're also saying, so this sign right here is the infinity sign. What it's actually telling us is one instance of this ID. So let's say author ID number 1, that ID can appear in here 0 to many times. So maybe that author hasn't written any books yet, but we just have that author's name in our author list. But that author might match maybe 1 time, which means that author has written 1 book, or that author might have written 10 books, which means it's going to be basically this star symbol, so the many sign. And basically, it kind of follows the same thing. In this case, the combination of author and title has to be unique. So I can't have that author appear multiple times for the same title. It has to be a different identifier. So it kind of just follows as well. So in here we have title ID. The titles have to be, at least the title IDs have to be unique. And this is your one side. And probably just one more in here. And this is fairly common. So right in here, we also tend to call this the strong entity. So let's say titles, because that's where your one side is, and authors, that's your one side, which means those are, you can think of it as master lists. I have a master list of titles and a master list of authors. And this is your one side too. And when you have a potential many-to-many relationship, if a title can be written by many authors and an author can write many titles, in a relational database, we typically create what's called, it's called associative entity, but it's like a mapping table. So now I have a map of the authors and the titles they've written, and then the titles and the authors that are related to them.
Okay, so those 4 yellow keys in the title box, that title table, you have 4 yellow keys connected around it. So it means it has relation to all those different tables that's around it, correct?
Yes.
And the infinity sign means this author may have, so for example, from the titles, it's going down to the title author, and it's an infinity sign down there. And that means this author has many books. Is that what it is? Is that what it is representing?
Well, yeah. So this infinity sign.
From the titles, the yellow key, it goes down to title author, right? What does that mean?
Yes, it means a title can be associated with multiple authors. So maybe think about an author, a book where there's like 3 authors, kind of a collaboration. Then it could potentially match to multiple authors. And also in here, with this title ID, and you see all these keys that are coming from title, it means that we are going to use that as a foreign key, and we can kind of trace it. So that's the title ID that's related to sales, title ID that's related to author, title ID that's related to somewhere here. and the
Sure.
royalty schedule.
Okay.
Yeah. Yeah.
Okay. All right. Thank you.
Okay,
Yeah, you're
I just
welcome.
want to add one thing, Jaya. I think it might Donabel explained in a very good way, but the problem with relational, or the most important property of relational database is that it has to store information related to real entities somehow. So when we are talking about a library system, for example, we have author and we have books. Now,
Yes.
for example, this is the major, and we have the titles. Now, this can be logically decided from understanding how to build the system itself. Now, this is, I'm going back to how you create the system, how you create this database. Okay. Now, once you decide the main entities, the major entities, which is most probably it will be linked to real entities in the life. Okay. Once you describe it, you will find what is the relation between these entities.
Okay.
And
so in this...
to ensure that you have granularity and you are able to reach all the data that you have, in relational databases, there is some kind of concentrate or instruction that you have to follow. At the end, for one cell, in one row, you don't have to store more than one information. So if I'm talking about the authors and the titles, for example, if I add a column in the authors table named as titles, and I add all the titles of this author in that column, at the end, I'm unable to reach that title, specific title, I'm unable to reach it. Because whenever I use SQL to get information, I will get all of these titles together. So this one has to be splitted out, has to go out of the author into new entity, which is something I have to make it. This is the title of this author. Now, how to do that? There is some instruction, but at the end, there is 3 relations between each and every table. One-to-one, which is almost kind of, this is the author and this is extra information related to him, which is not always available. Okay, either it's one time available or it's not available. There is also one-to-many, which is just like the authors and for example, the titles. There is also, by the way, here authors and titles are many-to-many, sorry. Okay, which is the 3rd type. Many-to-many, it cannot be done. We have to create a new entity to implement it. Now, when we understand how this is created, it will be easy to query it.
Correct. Yeah.
This is yes.
Exactly. So in this example, one-to-many. So for example, from the title one to many, the title author. Is that a correct way of saying this? One-to-many?
You have to say it in another way. You have to say that authors and titles, they are many-to-many relationship. Okay? Authors, the author, he can be the author for many titles, and one title, it can be for multiple authors. How to implement this in relational database? We have to create that new table, which is title author.
Okay. So in
just to implement this one.
Okay. So Donabel, in your example over here, which one here says one-to-many? Is that the key from the infinity? Is that considered one-to-many?
Yes.
One is the key, infinity is the, sorry, Donabel.
Yeah, go ahead.
And what about many-to-many? Where is many-to-many? Where would I see that in this diagram?
You cannot see it in this.
Okay, gotcha.
That's what he was saying. You can't have a many-to-many. That's the whole point. You can't actually have a many-to-many.
We have to differentiate. This is generated by SQL Server Management Studio, my favorite tool. Okay, here it's showing how it's really implemented. Maybe in the design time, there is some DBA architects, they like to not mention the many-to-many, not break the many-to-many, okay? So they can put it on the design time, but the implementation, it cannot be implemented.
So it's ideally better to break it from one-to-many, right? Isn't that much easier?
Yes, it was many-to-many. Many-to-many, it's a break into two one-to-many relationships. This is how it's implemented always. Okay. So this is how. So here, how I understand the authors are related to the titles by many-to-many, because I checked and I found the 2 primary keys on the title authors, the 2 identities, which is the author identity and the title identity, in the title authors table. So here it's become clear for me that this is many-to-many relationship, and we implemented into this new table. We create this new table and break it into one-to-many.
Okay. So this breakdown that happens, this ERD breakdown, is this whole thing called ERD, correct? And you have the keys connecting to different tables. And how do you come up with this whole idea of this design? I mean, how does that work? When you have hundreds and hundreds of columns and rows and data, how does that come about, I guess? How do you design this? How does one design that?
Donabel.
I would say this is the foundation of any building.
Sorry,
I can answer.
Is,
Yes, Vikram, go ahead.
no, I would just say that if your database is compared to a building, this is the foundation plan. Without ERD, we can't construct it. First, we will build an ERD, then only we will create a database.
Yeah, how do you build the ERDs is what I'm asking.
There is two methods.
Jaya, if you, just a simple thing, but I was going to say, usually before you get to this physical implementation of this model here, there's a logical model, what they call a logical data model. And so in a logical data model, you are really just thinking about what are the business rules, what's going on with the data from a business perspective. Okay, and so like here where you've got the author and titles, you might in a logical model just have the titles and the authors and have a relationship between title and authors, and you're going to have a many-to-many on either side of that. And then the logical model is you're working through the process. So you're going to start with that higher level. So maybe you figured out, you know what your entities are, you're working on your attributes, you're doing your metadata, you're going through that whole process. Then you're going to create a second model. Okay. And in that second model, then you're going to start looking at, okay, well, you know, it's kind of like you're going from this logical to an actual physical thing that you can implement. So it's like you can do this in steps, because also in a logical model, like in your physical model here, you have a key field, and it's usually a random number. Well, in your logical model, your actual business key may be 4 or 5 attributes, but you don't want to put that in your database model because that's just going to be difficult to deal with. So, but the thing is, in the logical model, you can put all of this stuff out and think about how this works from a business perspective. And then you want to think, okay, what's the implementation of this? And that's when you're going to get down to these kinds of issues.
So
I mean, I'm just kind of giving you a high level view.
Sure. No, I think that was great explanation. Thank you, Valerie. And this logical model that you're sharing, Valerie, is that something that is done on paper? Is it something that you draw it out? Or?
Well, it depends on the size. I mean, you can do it on pencil and paper. But there are tools. For example, one of the popular ones is the ERWin model, a modeling tool that's used. And so that does allow you to do a logical and a physical model. And so as you're you know, going through that process, you can then work through the logical model, and then you can also, you know, adapt it to your physical model. So
when you say physical model is what Donabel has here, is that what it's called? Is that a physical model? What the physical model
like
is? What
a physical model,
like what she's showing me right here.
Yeah, the ERD is the physical model.
Okay, gotcha.
Jaya, just one last point. Designing the database itself, it can be very. There are some people, they are able to do it on fly. That means just understanding what is the business really and what is the key entities that we find in the business. They can decide what's the logical model and go ahead and start implement it. Now, to do that in systematic way, we have what Valerie shared with us. Yes, really, this is helpful method. The other method, it's what we name is the normalization, which is create kind of huge table, Excel table, for example, or whatever, that contain everything, and then you can follow some, we name it normal forms, 2-3 normal forms. According to that, this huge table will be split into tables and entities, and the physical model will be generated. Now, this is how we follow it. The normalization method, it's normalization is more than it's constraint that we have to follow. Personally, when I work on something, I didn't think about normalization because I tried a lot, and currently whatever I do, it will be normalized 100% from database point of view. But this is systematic way. That means even if you are not sure, you can follow it. Just add everything in one huge table, and then follow the 3 major formal normal forms, and you can come with the physical model that you are looking for.
Raif, can you please describe the 3 major normal forms?
Never. It will. Why? There is a reason. I will share it. I promise. I will share it with on the Slack channel. But I think the today it's for Donabel. It will be very long.
Donabel, can you share the 3 normal things?
I think the I think it's so I think what Guy has said is actually right. Like that's what the normal forms are. So typically what we do is, if you imagine it to be, if you imagine all your data to be just in one Excel file. So in here you might have like multiple columns, and you have all the attributes, everything in one Excel file, one tab. So let's say you have an ID in here for your first name, for your last name, their address, and then the book that they wrote, let's say. So book ID, so 1, 2, let's say 3, and then the book title. So you can get, if you imagine starting with a single table, and then now you start seeing that, for example, number 1 is Jaya. Number 1 is also Jaya. Number 1 is also Jaya. And you're appearing here multiple times because you wrote 3 different books. And you're going to see a lot of what's called repetition, redundancies. So again, like even just visually, we can see that's probably wasted space. Like I'm going to have a problem if you decide to, change your address. I have to trace all of those. So the normalization piece is our way of making this more lean. So instead of having all of these in one line, so for example, this is what you call your unnormalized form. When you go to the first normal form, you kind of split it up. And then typically you're going to end up with at least 2 different tables, because in here, again, just visually, we can see that maybe that's an author, and maybe that is a title. Okay. So first normal form is usually identifying and making sure that we don't have repeated data. The second normal form, now we kind of go into what we call dependencies, and might be for a different session. But this, for the second normal form, it's called partial dependencies. And that's when we're starting to look at keys. So for example, Jaya right here, if we decide that our ID is, this book ID and this book ID. So the combination of those is our primary key now. The way we decide our second normal form is by really looking at individual columns. So for example, if I'm looking at Jaya right now, and if I know my primary key is 1 and 1. So a primary key, by the way, is the unique identifier, and its sole purpose is to be able to identify the record. So if I pass in ID number 1, I should be able to pick this record. But if you take a look at this one field, Jaya, do I really need to know the books that you have written? Because in here, do I need to depend on the book title for me to know your name? And the answer is probably not. And that's what we call partial dependency, because this first name only depends on the author ID. It only depends on one part of the key. So typically when we go to the second normal form is we split it up whenever we find kind of a partial dependency. And the final one that is usually used kind of most practically, but there's a lot of other normal forms other than this, is the third normal form. And the third normal form is all about what we call transitive dependencies. And the transitive dependency happens if, for example, so let's say in here, I have a publisher ID, and then, publisher name. But this ID right here, let's say A, that ID right there is not part of my primary key. So my publisher name, if I ever need to know the publisher name, why do I need to use this author ID and the book ID? Because technically all I need is this publisher ID. But we have a problem here because our rule was the primary key should be able to identify all these columns. But now we're saying, oh, actually, I don't really need any of the primary keys. I'm depending on a non-primary key. And that's what you call your transitive dependency. But I think to what Wright has said, and I'm so sorry if I'm mispronouncing your name, but what Wright has said, a lot of times we actually don't go from unnormalized to like third normal form. A lot of times we think in third normal form. And that's why sometimes it's hard to even visualize this, because when I give you this data, you probably already know, oh, I need an author, I need a publisher, I need a title. You probably don't even think of like mixing and matching, you already know that's a thing. That's an author, that's a person. This is a title, it's a book. You can visualize it in the real world. So I think that's mine.
Cool. Thank you, Donna. Thank you to everyone giving me the explanation. I think it's great. Thank you so much.
Yeah, also please note the chat. Vikram has described it as well. And I think that was an excellent, excellent breakdown, Donabel. Thank you. Now I understand transitive, which I didn't understand before. Thank you.
Welcome.
Just in because we're coming towards the end, I wonder, Donabel, if you have any resources.
Kim, we can't hear you.
Glad that you could tell me that.
Sorry.
So I was saying, thank you so much, Donabel, for describing this. And I wondered, since we're coming towards a close, if you could share some resources with people, obviously, besides going to your YouTube courses and following through what you talk about on SQL, but things that might help Jaya, for example, in understanding the thinking behind design database or database design, and then resources that the class can use. And please, anybody else hop in with any thoughts on chat. Thanks very much.
I think there's a lot of really good books on databases, but when I was learning, this was one. The database that I used a long time ago that was very helpful for me was actually this. And again, there's a lot of fantastic books there right now. But so this is kind of a second version. I used the first version, but this was helpful for me. I kind of definitely related, I'm a mere mortal, because a lot of the other databases, they dive into like, there's already an assumption that you know how databases work. But I thought, and so I read the first version, and the first version, the reason it was good to me is because it started with a question. It always started with a question, and they always broke down what you needed to do. And the other reason I really liked this is it gave examples on different ones. So I saw how it would be different in MySQL. I saw how it would be different in Oracle. And in some ways, it gives you a little bit of confidence that, oh yeah, they're kind of the same. You can kind of see the minor differences, but the general approach was the same. So I think this is one of many really good resources on SQL or databases. But I think personally for me, this was one that I used a lot.
Thank you.
Yep.
And
I would also add, sorry, go ahead, Vikram.
Follow Eric Weber on LinkedIn. He posts so much data related to SQL, and it's very helpful.
Yeah, absolutely. Yeah, Eric Weber.
Yeah, and in terms of people to follow, definitely check out Danny Ma for anyone who doesn't already know him, Eric Weber, and I think also in terms of SQL stuff, there is a lot of stuff that is on LinkedIn. Definitely check out the SQL cheat sheets, check out the references that people are using for books, because there's a lot of them that are put out there. And if anyone has any other questions about SQL, please feel free to join us again. Pop them in the chat. We will try and post them up for our members to try and respond to. And we do have the segments in the Slack channel. So if anyone needs any tech help, that's a good place to ask questions as well. Thank you so much, Donabel. Every time you come, it's just so inspirational and so lovely to hear you. I really, really appreciate it. I'm sure everyone else does as well.
Thank you. No, it's always great to be here, listening in, sometimes presenting, and thank you for all the questions.
Oh, I have one last question, which probably isn't as relevant as some of the other stuff that you've been talking about, but it was really interesting to me. I'll take myself off this thing here. What was really interesting to me was that you had done so many classes where you were in this old world sort of correcting papers. And I wondered if there were mistakes that you saw recurring over and over and over again.
Yeah, I think that's the challenge. I think I marked for at least 3 years. So I've been doing that every time, like every term. It's like always like this. It's at one point there was like 150 students. So yes, there are definitely recurring errors. So a lot of them will happen usually in the where clauses, like what you put in the condition and how you put the condition, and the from clauses. So a lot of people will not be able to like match. Like when you're comparing with another table, you need to know what fields to match. So that's also another one. And yeah, I think at some point, you know, on the 100th paper going to the 120th paper, you're already thinking, it feels like I already told you how to do this, but you know, it's a different student, right? And you kind of keep on going. So I would say I was also a bad marker, because usually when you're a marker, the instructor or the teacher gives you a cheat sheet. It's 1 mark for the select statement, 1 mark from the from clause, 1 mark from the where clause. And I just couldn't, and I've talked to the instructor too, so I didn't really kind of go rogue, but I talked to the instructor too. I'm like, I really can't accept that, in the sense that if somebody else gave me a totally different form, but if I can visualize it gets me the answer to your question, why would that be wrong? Why should I deduct marks? So I've always had this conversation, because with SQL, there's not one way to do things. I could be doing it using a join. I could be doing this using a view. I could be doing this using something else, and I'm still getting the correct result. And if the most important thing for an exam is that the students know how to get the results, then they're achieving that. So I was very reluctant to deduct marks because of that. And I also was very reluctant to give majority of the marks, even if they checked off like the select and the from and the where, but it's absolutely wrong. So yeah, I was kind of a rebel, I guess.
I think it's great, because I think that you raise a very important issue, which ties back into what you were saying before about efficiency. And that's that there's a lot of ways to skin a cat and a lot of ways to get at the information that you want, but not all of them are going to be efficient in terms of the time that the query takes. And so that is a really great point. And I wanted everyone to note that Vikram has posted, in addition to the Learn SQL and W3 schools that Tom mentioned earlier, which is mode.com. So if anyone wants to look into these things, by all means, I will check out that. I've never been to mode.com, so I'm gonna check that one out too. Thanks, Vikram.
To be honest, mode is super helpful, and I have witnessed 3 or 4 my SQL assessments on mode.com. So they're very helpful, and it's very useful to, like, we can practice on the real world data sets. Like, it is similar to Kaggle. There are so many data sets where we can practice. I mean, databases.
Cool. Yeah, and actually Vikram makes a really good point, which is also that if you are participating in any kind of Kaggle challenges or any kind of data for good challenges, a lot of times they will throw you SQL data that you can use to analyze. And so it's really good practice for real world stuff. All right. Well, unless anyone has any additional questions, thank you so much, Donabel. This has been awesome. And, you know, we will be recording this so you can review that for anybody who had to leave early. Sorry, we lost you, but looking